Okay. Okay. Hello and welcome. Today we are going to spend about 45 or 60 minutes inside Microsoft Fabric working with something that sits underneath almost everything you do in a Lakehouse. Whether you realize it or not, Delta Lake. So here is the shape of the session. We'll start by creating a workspace and a lakehouse from scratch, and we'll load a simple CSV file of product data into it. Then we'll open a notebook, read that file into a Spark data frame, and save it as a delta table. That's the foundation, and it takes us about 20 minutes. After that, we get to the interesting part. We'll change some data and then we'll go back in time and look at the table exactly as it was before we changed it. We'll run analytical SQL over the table and build a chart from the results. And we'll finish with streaming. We'll point a live data stream at a delta table and watch rows arrive while we are querying it. Everything I do you can do alongside me. All you need is a Fabric workspace with capacity attached. If you would rather just watch and do it afterwards, that's fine too. The code is all in the materials. One request before we start, if something goes wrong on your side, drop it in the chart as it happens, rather than saving it to the end. It's much easier for me to help you at the moment it breaks than 20 minutes later. I'm just going to be sure that everything is okay. There is nothing, no issue with live streaming. I hope it's okay. Great. So let me set up a problem we are solving because it explains why delta exists at all. Imagine you have a folder of Parquet files in a data lake. That's a very common starting point. It works well for reading and it scales beautifully. But now imagine two things happen at the same time. One job is writing new files into that folder while another job is reading from it. The reader sees a half-finished picture. Some files are there, some aren't. There is no such thing as a transaction. There is no such thing as the state of this data at 9 a.m. And if you want to update a single row, you can't. You rewrite files by hand and hope nothing else touched them in the meantime. Delta Lake fixes exactly that. A delta table is still just Parquet files in a folder. That that part hasn't changed, and it's important because it means your data is still open and still yours. While delta adds is a transaction log sitting next to those files. Every write, every update, every delete gets recorded in that log as um, numbered verbally. That one addition buys you three things that matter today. The first is ACID transactions. Writers don't corrupt readers. A write either fully happens or it doesn't happen at all. The second is time travel. Because every version is recorded, you can ask the table what it looked like at version 0 or at any version since. We'll do that live in about 20 minutes, and I think it's the moment where delta stops being an abstraction. And the third is that batch and streaming stop being two different worlds. The same delta table can be a destination for a nightly batch load and for a live stream at the same time. We'll demonstrate that too. In Fabric, this isn't optional or something you switch on. Every table in a lakehouse is a delta table. So everything we look at today is already running underneath the work you are doing. Right, let's build it. Okay, let me share my screen. There is nothing for now. So let me drag and drop new web browser. Okay. So what I'm just going to do now, so I'm going to be on Microsoft Fabric homepage and signed in with my Fabric credentials. On the left-hand menu bar, I'll select Workspace later. So either I'm going to add app.powerbi.com or app.fabric.microsoft.com. And I'm going to use my credential to just sign in. So here I have I have already signed in using my credentials. So, and that's okay. Then I'm going to select Workspaces. So I'm creating a new workspace and I'm going to call it Delta tables underscore workspace. So say new workspace, Delta tables DT underscore just workspace. Okay. Let me add also a description, say lab purpose only. And now the important part is hidden here. In the advanced part section, actually, here we can find the hidden part. I need to choose a licensing mode that includes Fabric capacity. That's trial, Fabric trial, or premium or Fabric. So I'm going with Fabric trial, and then I say apply. So if you skip this, everything looks fine until you try to run a notebook. And then you'll find Spark isn't available to you. So if you are following along, expand advanced and check this one. And that's our workspace. Empty as you would expect it. So quick one for the chat. How many of them already have a Fabric workspace of your own? And how many are creating one for the first time today? Just curious what the room looks like. So I'm going to also just copy and paste my questions in YouTube chat box. So let me do it. And I hope I will get the necessary answers. Okay. Now we need somewhere for the data to live, and that's a lakehouse. Okay, so let me go to my workspace, and here I'll select new item. And then I will choose Lakehouse. I'll name it Delta Lakehouse. PT, something like this. Okay, Lakehouse. And here is a checkbox I want you to pay attention. Lakehouse schemas. Leave it selected. This gives our Lakehouse a schema layer, which means our tables live under a schema named DBO, exactly like they would in a relational database. Every piece of code we write today refers to tables as dbo.something. If you clear this checkbox, your tables won't have a schema, and every one of those references will fail. So leave it ticked. Then create, and it takes a minute or so to provision. And now Lakehouse is going to be open. There it is. On the left is the Explorer pane. And it has two things in that I want to distinguish carefully because the difference matters all day along. We have files, is unmanaged storage. It's a folder. You can put anything in it, CSVs, JSON, images, whatever you like. Fabric doesn't know or care what's in there. Tables is managed storage, and everything in there is a data table with a schema and a transaction log, queryable with SQL from anywhere in Fabric. The work we are doing today is essentially about moving data from the left-hand side of that distinction to the right-hand side. So let's start on the files side. Next to the files folder, I'll open the ellipsis menu and create a new subfolder called products. All lower cases. And I want to flag that deliberately. The path ends up inside our code. And it's case sensitive. If you create products with a capital P and then load files slash small products, I'm a small p, you'll get a file now found error. And it's an annoying one to spot because your eye reads straight past it. Now I will upload the data file. I've got products CSV already downloaded on my local machine. And I would suggest you download it before you start rather than in the middle. It saves a scramble. By the way, I have already shared the link where you can find the link for source file. Also, a link for text file where all the codes that I'm going to use today, Spark codes, can be found. Okay. So let me upload that file. So I'm going to, just what I'm just going to do. First of all, I'm going to, select this folder, product, to verify that I have already my subfolder, right? So let's select ellipsis, upload, and upload files. Then I'm going to select my products, CSV file, and upload. It's already uploaded. Let me close it. And I'm going to select this one, this products one, and I can verify that products.csv file already downloaded, uploaded into files folder of Lakehouse. Okay. So this is raw data that landed in Lake. And it's at this point exactly as useful as a spreadsheet on a shared drive. Let's fix it. To work with this data, we need code. And in Fabric, that means a notebook. From the Lakehouse, I'll select Open Notebook and New Notebook. Notebooks and New Notebook. Opening it, it this way matters. It attaches, the notebook to this Lakehouse automatically, which, is why we'll be able to refer to files and tables with no with short relative paths inside of long URLs. Fabric names this notebook like notebook 1, notebook 2, and so on. So let's click the name panel above the home tab and give it something you'll recognize in a week. I'll call mine explore delta tables. So yeah. So here I'm typing explore delta tables and enter. The first cell, this one, is a code cell, and I want it to be a markdown cell instead. There is an M below, arrow button on the cell toolbar, top right here, which converts it. So let's click on this, right? And then we are going to click on this pencil, edit one, right? Okay. So, and I'm going to type the next one. Let me copy paste. So here, let me click once again, and this one. Okay, and enter. Sorry, not enter. No need. Okay, so just we here entered some meaningful names like Delta Lake tables, and we gave some description. Then we can click anywhere outside the cell that renders it. That's 30 seconds of work, and I want to make the case for it because almost nobody does it. A notebook is not a script. It's a document that happens to run. A person opening this in 6 months, who may well be you, will read the markdown before they read the code. So get the habit, write it. So what I'm just going to do. So I'm going to hover over here below, and I see code. I'm clicking on this. So now the real work, new code cell. Actually, we have already added. And here is our first block of code. So let me paste it. Sorry. Actually, yeah. Once again, you will find the necessary codes. Just let me give, in the link that I have shared you in YouTube text box, chat box. And by the way, you can use any other AI tools or Copilot in Fabric just to generate these codes, right? Okay. So first of all, after pasting the code, I would like to read this code before I'm going to run it. Okay, so I think here is decision that worth understanding. So at the top, we're importing some types from PySpark SQL types, right? Then we build a struct type, okay? And that's a schema, and we add 4 columns to it. Product ID as integer, product name, string type, category string type, and list price double type, right? Okay, so each of those has a true on the end, which just means the column is allowed to contain nulls. Then we read the CSV, okay? And we pass the schema in explicitly. Now Spark can infer a schema for you. You have probably seen infer schema used. And for exploring a file quickly, that's fine. But inference means Spark reads part or all of your file just to work out the types, which costs time. And it means the types are a guess. A product ID that happens to be numeric today becomes an integer. Next month, a file arrives with an ID like A1042, and your pipeline breaks in a way that's hard to trace. Defining the schema is more typing, and it's the right answer for anything you intend to run twice. Also note header to is set to true, right? So the first row is treated as column names rather than data. So let's run it. And here, now the first run is going to take a minute or so. And I want to tell you why rather than just letting us sit here. Nothing has been running until that moment. When you hit run for the first time in a notebook, Fabric has to allocate the Spark session for you. That's a driver and set of executors, actual compute, and spun up on the capacity we attach to this workspace. That allocation is the minute we are waiting on. Actually, I hope it has already been completed. So let me complete my thoughts, right? So the allocation is the minute we are waiting for. Every subsequent cell in this notebook will run against the same live session. So they'll come back in seconds. This is a one-time cost, and it's worth knowing so that you don't panic the first time you demo this to your own team. Okay, so here output appears. So there we go. And that's our data, a table of products with an ID, a product name, category, and list price. The display function is a Fabric, helper, this one, right? And it gives you this interactive grid rather than the plain text output you would get from Pro. Worth noticing that we have and haven't done here. We have a data frame that's in memory, session scoped object. If I close this notebook, it's gone. Nobody else in the organization can see it. It's not a table. Let's make it one. So one line does it. So let me copy my line of code. And here, new code and paste. So we take here with this line, the data frame, we write it in data format, and we save it as a table called products underscore table. And it's going to be under DBO schema. So if we go to, here, just pay attention, the code says products underscore table. Okay, so that's the schema we get by leaving the schemas checkbox ticked earlier. So let's run it. And the word managed is doing quite, in the phrase managed table. It means Fabric owns the life cycle of the underlying files. And we didn't say that where to put them. Fabric put them in the Lakehouse's tables area. If we drop the table, the files go, with it. So what I'm just going to do, I'm going to my, I'm here in this, Explorer. So in front of tables, I'm clicking on ellipsis and say refresh, right? Okay. So we have already run it, okay? And let me expand this one. So here we have products. Yeah. Okay. So let's go and look in the Explorer pane. Actually, I have already refreshed this table and expand it. So then we can see products table here. Notice the little triangle, this one. This is a triangle icon, and that's the delta integrator. Anything with that triangle is a delta table with a transaction log behind it. So here is what just changed, which is more than it looks. That table is now visible to the entire Fabric workspace. The SQL Analytics endpoint can query it. Power BI can build a semantic model on it. A colleague in a different notebook can read it by name. 30 seconds ago, that was a CSV in a folder that only I knew about. It's now a first-class object in, platform. Now we get to the part that I think makes Delta click for people. I said earlier that every change to a Delta table is recorded in a transaction log as a numbered version. Let's test that claim by making a change and then going looking for the evidence. So let me add new code and just I'm going to paste that code. Control V. So this is my new code. Okay. So here is our change. And we're giving mountain bikes a 10% discount, right? So two things to point out here. First, that double percentage SQL at the top here is a magic command. It tells the notebook to treat this entire cell as Spark SQL rather than Python, right? And you can mix SQL cells and PySpark cells freely in the same notebook, working against the same tables. And I use that constantly, right? So second, and take a moment on this, we are running an update, this one, update statement against a file in data lake. That's not a thing you could do a few years ago. Updating a single category of rows inside a folder of Parquet files with a transaction around it is precisely what Delta brought to the party. Let's run. And so done, I think. So yeah, and mountain bikes are now 10%, cheaper. Now the old prices, where did they go? In a normal file-based world, the answer is gone, unless you took a backup. Let's see what Delta says, right? So I'm going to add one more, code line and Control V, right? And here is a transaction log, made it that's going to be readable. So let's run it. Okay, so let's look at version column. Okay, so version 0, this one, is the original write. That's the save as table we ran 2 minutes ago. Version 1, this one, is the update we just ran. Each row has a timestamp and the operation type and details about what the operation did. This is not something we turned on. There is no configuration for it, no audit feature we enabled. It's simply how the table works. Every table in your Lakehouse has had this the entire time. So we know version 0 still exists and can be queried. We can, and syntax is just lovely. So let me add one more line, and I'm going to use this code. Okay, so here, let's just run. I think it's going to be a problem, but let's run. Let's try to run, and I will give the necessary explanation. So actually, it's going to read the from, from close carefully. Actually, it worked. Yes, that's perfect. And because this is the whole idea in one line, from DBO products table, version as of 0, right? Uh, the same table as it existed at version 0. And then we join it to the DBO products table, right? This one. With no version qualifier, which means as it exists right now. And we are joining a table to its own past. So here we have our just results, right? And every mountain bike with the price it had before and before the update and the price it has now. You can see the 10% coming off each row. Let me concrete about you would care because time travel sounds like a party trick and it is. And until it isn't. A pipeline runs overnight and corrupts the table. You don't restore from backup. You read the version from before the job ran. Someone asks what a report would have shown at month end, 3 weeks after month end. So you query the table as of that timestamp. An auditor asks what changed and when. Describe history is your answer. And you didn't have to build anything to have it. One honest caveat, so you are not surprised in production. History isn't infinite. Delta retains all the versions according to a retention setting, and maintenance operations like vacuum remove files that are no longer needed by any recent version. So time travel is a recovery window typically measured in days, not a permanent archive, right? So plan accordingly. I would be interested. Has anyone in the chat had a situation in the last year where being able to reduce this version of table would have saved you an afternoon? I suspect if you have. So I'm going to also copy and paste my question here on YouTube. So let me do it, right? Okay. So let me go back to our fabric environment. Let's do some analysis on this table and pick up a technique on the way. So let's add just one code, right? Okay. And I'm going to create a temporary view. A view is just a named query. It doesn't hold any data. It holds the definition of a query. And temporary means it lives as long as the Spark session and then disappears. It's not an object in the Lakehouse. And your colleagues can't see it. So let me copy and paste this one. So the query itself is a straightforward aggregation, right? For each category, how many products, the cheapest, the most expensive, and the average. So we can see it here, number of products, median price, maximum price, and average price, right? The reason we wrap it in a view is that we are about to ask several questions of this same summary. And without a view, we would be pasting that group by into every one of them. Give it a name once, use the name afterwards, and your notebook gets shorter and your intent gets clearer. So let's run it. And I think I'm going to get my summary by category, and we can see the count and the price range for each one. Wow, unfortunately, we're going to get a mistake. So here, what I'm just going to do, this is due to this one. So let me just delete that one and run it again. I hope it will work. Yes, it worked. So here I have my, output. And this is the summary by category, number of products, minimum price, maximum price, and average price. Now, let's add one more, just, say um, code. And I would like to watch how short the next query is, right? So let me copy and paste. So I'm going to, just see 10 top 10 categories by number of products, no aggregation logic inside, and it's all hiding behind the view. Just let me, you know, run, and results are appearing here, right? And we don't have to leave the results grid to visualize this. So what I'm just going to do, I'm going to click on this new chart. So I'm getting this visuals. So Fabric just suggests some charts based on the shape of the data, and I'll take one of them. And there is our just distribution. I want to be clear about what this is so far. This is an exploratory chart. It lives in the notebook. It's for you and whoever reads your notebook. And it's how you check the shape of your data while you work. It's not the reporting layer. For that, you would build a semantic model and a Power BI report on top of the table. Different job. But being able to see the data without switching tools is a genuine improvement to how quickly you can, iterate. So let's add one new code. And last one in this section, and it's here to make a point about mixing languages, right? So let me paste. Okay. And we are using here Spark, PySpark SQL, to run a SQL query from Python. And what comes back is a data frame. So we can carry straight on what data frame operations here we order by average price descending and take the top six. So that's the pattern I would encourage. Use SQL for the set-based, work, where it's the clearest way to express what you want. Then hand the result to PySpark. When you need something SQL is awkward at. Complex transformations, machine learning, custom functions. There are two interfaces onto the same engine and the same data. So use whichever one makes the line of code you are writing easier, just to read, right? So let's run. And so here, last just section, and it's the one that surprised people. Everything so far has been batch, and data set still while we worked on it. But delta tables can also participate in streaming. A delta table can be a source that a stream reads from, or a sink that stream writes into. So we're going to build a sink with a simulated Internet of Things scenario, devices sending status, readings. So let me add one more cell for code. And I'm going to paste the code in this cell that does two jobs. So I'm going to split them. So first of all, let me paste that code. Okay. Control V. Okay, that's it. So first job, we create a folder at files data. So files data, we create a folder, right? Okay, and then we define a streaming read over it. That's Spark read stream, right? So here, Spark read stream, right? And same idea, but instead of reading what's there and finishing, it watches the folder and treats every new file that appears as new data. Note, max files per trigger set to 1. Okay, so this one. And that means process one file per batch. In a demo, that gives us nice visible increments rather than everything arriving at once. Second job, we write a file of JSON records into that folder. 9 readings from 2 devices, right? Yeah. Okay. Some with stats okay, and some with stats error. In the real world, this folder would be fed by an ingestion service. Today, it's fed by us. So let's run. And we are looking for a message source stream created. This one. So there is it. There it is. So now nothing is consuming that stream yet. We have defined the read and we haven't started anything. Let's give it somewhere to go, right? So new code and let's type this code. Control V and 3 things here. And all 3 are words a sentence. The path, table DBO IoT device data. Okay, so we are writing into the tables area rather than files. And because of that, Fabric will automatically surface it as a table. We never write a create table statement. The table comes into existence because delta data appeared in the right place. The checkpoint, place, location. This is how Spark remembers which files it has already processed. If the stream stops and restarts, the checkpoint is what stops it reprocessing everything from the beginning. It's essential. And it's also the thing that cats people out when they rerun a demo. A stale checkpoint from an earlier run makes the stream think there is nothing new to do. And start this one, right? That's the moment the stream actually begins running. It runs in a background continuously until we stop it. So let's run. And streaming to Delta sync, let's check whether we see this. Yes, streaming to Delta sync, right? Okay, so it's live. And let's add one more code line. Here, I'm going to query it as an ordinary, table. So I'm pasting this code, right? And I'm going to run it. So if IT errors with table or view not found, okay? So that's the first micro, right? Okay, say, yeah. That's the first micro batch not having committed yet. The table appears the moment the first batch lands. Give it a few seconds, refresh the table's node in the Explorer and run it again. If we have, tables with errors or just not found, error message, but everything is okay here. So, and my rows are appearing. So there are our device readings, right? 9 devices, okay? And notes, we are querying these with plain SQL, the same syntax we used on the batch table earlier. From the reader's point of view, where there is no difference at all between a table fed by a batch job and a table fed by a live stream. That's the point I most want to land in this, section. So now let's simulate more devices, reporting in. So what I'm just going to do, 7 more readings written as a second file into the same folder. We have not touched the table. We have not run and insert, we have dropped a file into a just, folder. So let's add this code and say run. So yes, this is going to be true. And now, yeah, okay, I'm just going to run this one again. Yeah, now we see, 16 rows here. Okay, 16 rows. The stream picked up the new file, processed it, and appended it to the Delta table while we were talking. And the query we wrote before that data exists returns it without modification. That's the whole promise of a lakehouse in one screen, one table, continuously fed, queryable by anything in the platform, with no separate serving layer to build and no synchronization to manage. So let's add one more, code. Okay. So what I'm just going to do, let's come here. So this time I'm going to just write or paste one line, code. So this is the last thing that let's not skip it, right? And as soon as I'm going to, run it, the stream is running in the background and it will keep running, holding resources on your capacity until it's told to stop, right? Okay, so stop your streams when you are done with them. It's the streaming equivalent of leaving the lights on. Okay, so now it's time to clean up, recap, and time for questions. So if you were only doing this to learn, you can remove, you know, the whole thing. Select your workspace in the left-hand bar, open the ellipsis menu of the toolbar, go to workspace settings, and in the general section, choose remove this workspace. That deletes the lakehouses, the tables, the notebook, everything. Do check you are deleting the right workspace. The confirmation dialog is not as loud as it should be. So let's do it. Workspaces. This is my workspace ellipsis that I described a little bit earlier, workspace settings. And from here, I'm going to, select, delete, remove this workspace and delete. So let's pull the thread together. We started with a CSV file in a folder, useful to precisely one person, me. We defined the schema and read it into a data frame. We saved that data frame as a data table. And the moment we did, it became something the whole platform could see. Then we changed the data and we found the delta had quietly recorded both the before and the after without being asked. We queried the past and the present side by side. We ran analytical SQL over the table, wrapped a summary in a temporary view. So we didn't repeat ourselves and charted the result without leaving the notebook. And then we pointed a, live data stream at a second data table and watched row arrive while we queried it, with the reader having no idea and no need to know that the data was just streaming. The one idea underneath all of it in Fabric, every table is a delta table. And transactions, working, time travel, streaming support. You get all of it by default on every table you create, whether or not you ever ask for it. If you want to take this further, the next things I would, um, I would look at are merge for upserts, optimize and vacuum for table maintenance, and partitioning strategy for larger, tables. Thank you for spending the roughly 50 minutes with me. And let's take questions if there are. So let me check. Yeah, I don't see any questions. So what I'm just going to tell you about the upcoming sessions in DP 700 series, you know, uh, in my upcoming session, I'm going to demonstrate the lab for analyzed data with Apache Spark. So check my YouTube channel, subscribe it, right? So this is my channel. Just subscribe it, right? And you will find the necessary videos for your further, participation. And also, I would like to provide you with the my meetup group pages. So here you can find Azerbaijan data and the AI community, roughly 3,000 people. So I have very good meetups with good speakers from different parts of the world. So you can just, subscribe to my meetup group. So thank you very much. I'm going to, stop sharing. And if you have any question, you just can type your question. And I'm going to, yeah, actually, I have already shown my YouTube channel. And also, by the way, let me, yeah, I'm also going to type my, you know, um, email address in YouTube. So you can write me an email. So that's all from my side. So see you in upcoming session. So thank you for watching. I look forward to welcoming you in my next upcoming session. Bye.